This video is about the general rules of probability. So probability rule number 1 says that a probability is a number between 0 and 1. And think of it this way. We can interpret probability as the proportion of times that a certain event can be expected to occur. Probability of an event is more than 1, and that means it occurs more than 100% of the time. Impossible. Also, if a probability is less than 0, it occurs less than never, which is again impossible. So if you ever get a probability that is greater than 1 or less than 0, you know you've made a mistake and you need to go back and find it. Number 2. All possible outcomes together must have a probability of 1. That means if you add up everything that can possibly happen, the sum of the probabilities is going to add up to 1 because something has to happen every time. And if you've gotten all the things that can happen, then you've gotten all your probability in there. If it's less than 1 or greater than 1, that means you have a probability model that's incoherent. It doesn't fit together. You've probably either misassigned the probabilities or don't have a complete sample space. Number 3. Probability that an event does not occur is 1 minus the probability that the event does occur. It's called the complement. So say you think as a jury member that the defendant is guilty about 80% probability. Then you also have to believe the 20% probability that he's not guilty. That's just to be consistent with things. Or if the probability the flight will be on time is 0.7, then the probability that it says late, but that it won't be on time is 0.3. Either one or the other happens. Number 4. Two events have no outcomes in common. They're said to be disjoint. Okay? That means there's no overlap. They can never both happen. That's true, then the probability of one or the other is the sum of their individual probabilities. Okay, so think of it with this example. Age of a woman when giving birth to her first child. Under 20 is 25%. 20 to 24 is 33%. What's 25 or older? Well, it's whatever's left. And what's left? We have 58% taken, so that means we have to have 42% left. Because those are disjoint. A woman can't be under 20 and over 25 when she first gives birth. She's one or the other. There's no overlap. Those are disjoint. Okay, Venn diagrams are your friend. Use them because they will really help you visualize what's going on. So this is a Venn diagram showing what two disjoint events look like. Notice that there's no overlap between that oval and that strange kidney-shaped thing. But when they are not disjoint, that means they have overlap. That means they have outcomes in common, A and B. In a couple minutes, we'll talk about what that does to the probability that we figure and the rules that we use. Number 5. Two events A and B do not influence each other, and if knowledge about one does not change the probability of the other, they're said to be independent. Different from disjoint. Means no influence here, okay? The probability that they both happen will be found by multiplying their individual probabilities. So the hardest thing between these two rules is distinguishing between independent and disjoint. Independent means there's no influence from one to the other, but they can happen together. Disjoint means they can never happen together. Now here's an example. Suppose about 20% of incoming male freshmen smoke, And these freshmen are randomly assigned in pairs to dorm rooms, which means the assignments are independent. One does not influence the next. What's the probability that we have a match? Well, if both are smokers, that's 0.2 times 0.2 gives us 0.04. Both are non-smokers, it's 0.8 times 0.8, which gives us 0.64. So the probability of that match is 0.68. Either both smokers or neither is a smoker if it's a match. What about only one being a smoker? Well, now we have the complement of a match is only one being a smoker. So it's 1 minus 0.68 or 0.32. So it's an example that combines a number of rules. What if the pairs are self-selected? Self-selected means they get to choose their own roommates. Well, you'll have a different scenario because now it's not independent. Now there's influence. You're going to choose someone. You're more likely if you're a smoker to choose a smoker. You're more likely if you're a non-smoker to choose a non-smoker for a roommate. So here's the addition rule for disjoint events. Probability of A or B equals probability of A plus the probability of B. Just add them together. This is the one we've already talked about. But the general addition rule, we're going to encompass non-disjoint events. And so I want you to look at this piece right here that the arrow is pointing to. When we count A, we count that area. And when we count B, we count that area. Which means we count that area twice. And we're going to have to remove that double counting to be accurate. So the probability of A or B for non-disjoint events is the probability of A plus the probability of B minus the probability of A and B. So let's take a minute to look at this case study. I suggest you pause the video and take some time to read it. And we're going to look to see for the probability that the student is either an in-state student or a part-time student. So pause it, take some time to read it and understand it. Maybe try to draw your own Venn diagram. And then come to the next and restart the video and just see the Venn diagram that I've drawn for it. So here's all students. There's in-state, there's part-time, and there's A and B. Notice if I didn't take out that double counting of A and B, I'd end up with a probability greater than 1, which should be a huge red flag anytime that happens. Now if we looked at in-state but not part-time, A but not B, that's this shaded part. Okay, this is the last example. Choosing a death in this age group randomly, what is the probability that the victim is a female? Okay, so we're talking 3 different kinds of death. The number of female victims is 2,620. And the total number of victims is 14,099. Now again, back to this idea that probability is proportion of times that something happens. You would take the total number of females divided by the total number of people represented here, and you'd get 0.19 approximately, about 19%. So the probability that the victim is a female in this is about 19%.